Hello everyone, this is Dr. Mitesh Gala. Welcome to Rough Book, a learning companion.
Hi, we're starting with rational irrational numbers exercise 1C. 1C earlier was in different parts, about 4-5 parts, so I thought I'll make a video again. I'll make a better video for all of you. Okay, so here you go with 1C. Now in 1C there are only two major things which you need to understand. One is called as surds and second is called as rationalize. Okay, so first let's understand what is surd. So anything which is under the root, okay, and which cannot be solved is called as a surd. And what is not a surd? I'm not getting too much into depth into it because it's a very small topic, we're just touching and moving it. Okay, so if you have anything with a negative sign inside the surd or which is irrational, for example pi is an irrational number inside the surd, or something which can be solved, for example root 4, all these are not surds, whereas this is what is a surd. For example root 3 is a surd. Okay, likewise if you got 3 plus root 2 double surd, double roots like that, you will say it is not a surd because it's irrational. So all irrational numbers basically become surds, or even imaginary numbers are called as surds. Very simple. Let's not get too much into it, it's just one part and we just move on. What is more important is rationalize. Rationalize means you'll have something which is irrational and you'll have to convert it into a rational number, that is called rationalizing it. How? So you multiply the numerator and the denominator by the same number. So basically it becomes root 3 on top and bottom it becomes 3. Ultimately when you cancel you get back to this only. So the value remains the same, value is not lost, but in the denominator the root sign moves out. That is called as irrational. That is called as rationalizing the denominator. Now in the denominator you might have only one term or you might have two terms. For example, this way. Then how will you rationalize? So this time you have to multiply with the conjugate. Conjugate means the opposite sign. Okay. Why like that? Because when you then multiply the numerator, fine, but the denominator a plus b, a minus b. Formula, that's correct, that's a square minus b square. So automatically what do we get then is 3 square 9, 8. So your roots are gone, it becomes 1. So final answer is root 3 minus root 2. So the denominator is rationalized. Rationalize means not removing the denominator. Rationalizing means just getting rid of the root, that's it. So this exercise 1C, majorly we are going to talk about surds and rationalizing the denominator. So let's hit it. It's a good exercise and you will find a lot of sums in the exam based on this. You have to say which ones are surds, which ones are not surds. So surds, not surd. So the first one, if you happen to solve it, root 80, it is not a perfect square. Therefore it remains as a surd, right? The next one, 4 root 27. So 27 basically is 3 cube. So again I can't get rid of it, can't get rid of the root, therefore it is a surd. So 1, 2 both are surds. The third one also 5 root 128. So 128 is basically 2 root 6, 2 raised to 6, 2 to the 4 to the 8 to the 16, 32, 64, 128, sorry, 7 times. So still you can't get rid of the root, therefore it is a surd. Whereas the fourth one, basically 4 cube root. So cube and root can be cancelled and you can get 4 without the root, therefore it is not a surd. Okay, then these two, cube root, that is the fifth one, cube root 25 into cube root 40. So when you solve, it becomes cube root 25 into 4000, which is 10, and therefore again it is not a surd. Why? Because you are able to solve it easily, the root is getting disappeared. The next one, negative, as I already told you, is never going to be a surd. So negative 125, not a surd. Pi is also irrational, therefore not a surd. And finally the last one also, I taught you earlier, root with a root, not a surd. So only these three are surd, rest all are not surds. Okay, let's move on to the next one. That's only the part about surds, nothing else. So you really don't have to care about it. What you really now need to care is the rationalizing factor. So in this exercise or in this part, they are asking you how will you rationalize, matlab how will you convert this irrational number into rational. So with what will you multiply? So obviously 5 root 2 has to be multiplied with root 2. They are not asking you to solve, they are just asking you with what will you multiply. So you say therefore root 2 is the rationalizing factor. Rationalizing factor. That's it. Now here they are not talking about numerator or denominator or anything. They are just asking you rationalize. So root 5 minus 3. What are you going to multiply this with? Conjugate. That is root 5 plus 3. So you say root 5 plus 3 is the rationalizing factor. That's it. Nothing else you have to do. But now you're going to get some googlies. Let's look at the fifth one. Root 18, root 50. Come on, tell me what will be the rationalizing factor. Did you say root 18 plus root 50? Wrong. Why? Because you need to first convert this to mixed. How? So take factors of 18. Okay, so let's take factors of 18. 2 9s are, 3 3s are, and 3 1s are. So this 3 can be pulled out and 2 stays inside. Exactly the same way for root 50, it will be 5 root 2. So basically it's root 2, both are like terms. So 3 minus 5 will give me minus 2 root 2. So now for minus 2 root 2, what will I rationalize it with? Only root 2. Can you see the change? So you have to be smart. That was the googly I was talking about. So you say therefore root 2 is the rationalizing factor. Are you getting it? Exactly same way. Can you try the seventh one? Root 13 plus 3. Here this is already a pure surd. You can't convert to mixed surd. So directly we'll have to multiply with root 13 plus, not plus, minus 3. So you'll say therefore root 13 minus 3 is the rationalizing factor. Got it? That's it. Move to the next two. So I'll have to take a fresh sheet. So just allow me to do that. There you go. So we are getting into sum number 8. Can I request everyone to try that sum on their own and then come back? So the 8th one, 15 minus 3 root 2. Again this is a googly. Why? Because I can pull out 3 common. So 5 minus root 2. What will I multiply now with is only 5 plus root 2. So that's the rationalizing factor. So 5 plus root 2 is the rationalizing factor. Rationalizing factor. That's it. Can you try the last one? Come on, pause the video on your own, try it. Is there a googly in this? No, it's a normal question. So directly, because nothing can be done, so we'll say therefore 3 root 2 minus 2 root 3 is the rationalizing factor. Yeah, I made a spelling mistake here, sorry. Rationalizing factor. Got it now? What is rationalizing factor? Don't expect such sums in the exam. They are very simple. They're just a part for the bigger ones. Now these are the types you can expect. They are telling you to rationalize the denominator over here. So how are you going to do it? So let's pick it 2 root 3 root 5. What should I rationalize this with? So root 5 by root 5. So I will get 2 root 15 upon 5. You don't have to solve it further. The moment the root is gone in the denominator, you are sorted. You are not worried about the numerator. You are only worried about the denominator. Can you try the same way? Fourth one, 3 root 5 root 2. So what will I multiply with? Root 5 minus root 2. Come on, solve this. You cannot leave it here because they are asking you to solve as well. So it's going to be 3 root 5 minus root 2 upon root 5 the whole square, a plus b, a minus b. So I shall get 3 times root 5 minus root 2 upon 5 minus 2. So 3 times root 5 minus root 2 upon 3. 3 gets cancelled. So root 5 minus root 2. That's it. Are you getting it, everyone? How many of you got this on your own? Very good. If you are getting it at this stage, brilliant. Can you get this one? 3 parts 6. Come on, take the conjugate, multiply. It's very simple. So what's the conjugate? Root 3 plus 1. Hit it now further. Pause. Try on your own. If you do not get, only then come back. Okay. So denominator is slightly different now because both are same. So whole square and numerator. Denominator is a square minus b square, the same thing. So now here you'll have to apply the formula a plus b the whole square. So a square b square 2ab upon 3 minus 1. So 4 plus 2 root 3 upon 2. 2 common. 2 plus root 3 by 2 gets cancelled. So 2 plus root 3. How many of you got same? If you are getting it, you are really doing a good work. I am proud of you. Can you try this one now? root 6 minus root 5 upon root 6 plus root 5. So it's going to be root 6 minus root 5, no sorry, yeah, conjugate, correct, and root 6 minus root 5. So root 6 minus root 5 the whole square, root 6 square minus root 5. Come on, at least pause now and try on your own from here. So a square b square 2ab upon a plus b, a minus b. So 6 plus 5, 11, minus 2 root 30 upon 1. Upon 1 you write, you don't write, it's alright. You write, you don't write, it's alright. Anyways, let's go to the next one. Sum number 3 part 9. This is the last question in this segment. Can you give a try to it? Come on, at least now stop copying. So 2 root 5 plus 3 root 2 upon 2 root 5 plus 3 root 2. So what do you get then? So 2 root 5 plus 3 root 2 the whole square and a square minus b square. Let's see what can we do now. So a square, that is 2 root 5 the whole square, b square and 2 times ab, so a into b, whereas denominator is going to be a square. So 2 square 4 into root 5 is 5, so 4 5s are 20 minus 3 square 9, 9 into 2 is 18. Once again, see 2 root 5, how do we square it? So 2 square is 4, root 5 is only 5, because root 5 into root 5, root 25, which is 5, and then 4 5s are 20. That's how we got this, okay? Likewise here, 4 into 5, 20, 3 square 9 into 2, 18, 2 2s are 4, 3s are 12, and 5 2s are 10 upon 2. So what we'll get is 38 minus 12 root 10 upon 2. So pull out 2 common. So 19 minus 6 root 10 upon 2 gets cancelled. So 19 minus 6 root 10. That should be your answer. Did you get the same answer? If you're getting it, you're really doing a good work. Keep it up. Let's move to the next one, 4 part 2. Now this is a good question to look for in the exam. They don't say that you have to do anything. They just say find the values of a and b. So you take this part LHS only and simplify it. How will you simplify? So the same logic, rationalize the denominator with the conjugate. So minus. Now solve this further and in the end get the values of a and b. So root 7 minus 2 the whole square upon a square minus b square. So this is going to be 7 plus 4 minus 2 into root 7 into 2, that is 2ab upon 7 minus 4. So 7 plus 4, 11 and 4 root 7 upon 3. Now you have to write this in this same format, okay? So let's split this, 11 by 3 and 4 by 3. So we are splitting the denominator and we are writing this first, minus 4 root 7 by 3 and then plus 11 by 3. Why did we do that? Because in the RHS you have a root 7 plus b. So now we can compare and quickly say that the value of a is negative 4 by 3 and value of b is 11 by 3. Do you understand it now how to go about it? Yeah, very good question. You just have to solve normally and in the end connect this to the RHS, pick up the values of a and b. I have seen many a times people writing the value of a as minus 4 root 3 root 7. So this root 7 is not going to be a part of it, okay? Keep that in mind. Likewise, let's move to the next one, 4 part 4. Again the same way, find the values of a and b. So LHS, 5 plus 3 root 2, 5 minus 3 root 2. So multiply it with 5 plus 3 root 2 upon 5 plus 3 root 2. So what do you get? A plus b the whole square, a square minus 3 root 2 the whole square. So what do we do now from here? Come on, pick up. Pause, try on your own, get me the correct answer for a and b, don't go wrong, okay? So a square, 9 into 2, 18 plus 5 2s are 10, 10 3s are 30, root 2 upon 25, 3 square 9, 9 into 2, 18, correct? So 25 plus 18, 43 plus 30 root 2 upon, the difference over here is going to be 7. So now 43 upon 7, 30 upon 7 root 2. I am splitting this and now we can compare with the RHS, which is a plus b root 2. So therefore what is your a? 43 upon 7 and what is your b? 30 upon 7. Do you get it now? Easy? Am I making it really simple for you? Brilliant. Let me know in the chat box. Chat box means in the chat that you have joined in the Roughbook app. Come on, pick it up here. 5 part 2, just simplify, okay? So here you can do cross multiplication. So root 2, root 6 plus root 2, root 3, root 6 minus root 2. Whereas in the denominator you get a square minus b square. Opening this, I get root 12. Root 2 into 2 is 2. Likewise here root 18 and minus minus plus root 6. Denominator becomes 6 minus 2. Now here there are some chances for converting this into mixed. So root 12 can be written as 2 root 3 because 4 3s are 12 plus 2. Likewise this can be written as 3 root 2 because 9 2s are 18 plus root 6 upon 4. So in the end what you can do is you can pull out this 1 by 4 outside and then write 2 root 3 plus 2 minus 3 root 2 plus 6 and leave the sum there only. That's the only way you can present it right at the end. Even if you leave here, I don't think so your teacher should give it to you wrong. It should still be considered, okay? So did you get it? If you're getting it, you're doing a good job. If you're copying it, so sorry. Okay, now this is a typical 4-mark question in the exam and 100% you will see one sum like this in your exam, okay? So how are you going to handle it? You've been given the value of x and what you need to find is x square. So how are you going to find x square? So pick this up first, x only, okay? Do not square it. First rationalize the denominator, okay? So once you rationalize it and then whatever answer we get, we will square it. So don't square it right away right now, okay? So root 5 minus 2 the whole square upon root 5 square a square minus b square. So a minus b the whole square, a square b square minus 4 root 5 and here it will be 5 minus 4. So denominator sorted, 9 minus 4 root 5 is the value of x. Now what will your x square be then? So it's going to be the square of this. So we can say therefore x square is 81 plus 4 root 5 the whole square. So that is 16 into 5 80 minus 2ab. So 4 2s are 8 72 root 5. So finally therefore I can say x square is 161 minus 72 root 5. This is your first part that we got, that is only x square. Y square exactly same way. So pick up y first. Okay, rationalize the denominator. So root 5 plus 2 upon root 5 plus 2. Take it forward now and in the end square it to get your y square. Don't be in a haste, okay? So come on, pause, try on your own and get me y square to gain some confidence. So a plus b the whole square, a square minus b square. So this is going to be 5 plus 4 plus 4 root 5 upon 25 minus 4. So 9 plus 4 root 5. I think I have made some mistake. This is not 25, this is only 5. So 5 minus 4 is just 1. So we got the value of y. So what is y square? 9 plus 4 root 5 the whole square. So y square will be 81 plus 80 plus 72 root 5. It's the same thing except for the sign, okay? So therefore I can say y square is 161 plus 72 root 5. So we managed to get y square also. Now x into y. So just take these two and multiply straight away. So let me take a fresh sheet. So this is my part 1. This is my part 2. And now I'm getting into part 3. So part 3 they said xy. So root 5 minus 2. Root 5 plus 2. This is x multiplied by y. That is root 5 plus 2. Root 5 minus 2. So this gets cancelled. And here this also gets cancelled. So what you ultimately get is only 1. Now for the last part, fourth one, x square plus y square plus xy. So what is x square? X square is here 161 minus 72 root 2. 161 minus 72 root 5 in one bracket. What is y square? So 161 plus 72 root 5. So 161 plus 72 root 5 and plus xy, which is just 1. Now open all the brackets and let's see what answer do we get. So this is plus minus getting cancelled. 161, 161, 1. So 323. Am I right? 1 plus 1, 3. 6 plus 2, 12. Yeah, that's correct. Got it? Interesting. So you first find only x. Now here the major mistake is people directly square this to get x square, and they will never get it. It's going to be very difficult. So first rationalize, then square. Likewise rationalize, then square. Then xy was simple, and then get all the three parts together to get your final answer. Simple? Exactly same is your next question. Let's see if you can handle it. Sum number 8. Come on, pause and try on your own. You think you smart. I am sure you are. So let's do it. So 1 by x is what they want first. So 1 by x means 1 by 2 root 3 plus 2 root 2. Yeah, that's 1 by x. No. Your 1 by x will be once you rationalize this. So 2 root 3 minus 2 root 2. Now take this forward. So you will get 2 root 3 minus 2 root 2 upon 2 root 3 the whole square minus 2 root 2 the whole square. So that is 2 root 3 minus 2 root 2 upon 2 square 4 3s are 12 and 2 square 4 2s are 8. So that is 4. Okay. So I can pull out 2 common in the numerator, root 3 minus root 2 upon 4. So 2 ones are 2 2s are, so root 3 minus root 2 upon 2. This is 1 by x. Now x plus 1 upon x. So x plus 1 upon x. What is x? So x is 2 root 3 plus 2 root 2 plus root 3 minus root 2 upon 2. Okay. So now cross multiply. 4 root 3, not cross multiply but LCM. 4 root 2 root 3 minus root 2 upon 2. So 4 plus 1 5 root 3, 4 minus 1 so 3 root 2 upon 2. Is that what we get? I am not sure if my answer is correct. So just give me a moment. Let me think. Let me recheck if I have done it correctly. So 4 plus, okay. So 4 plus 1 5, 4 minus 1 3. I think it should be correct. I have no choice. Now you need to square it. So let's take a fresh sheet again and square it to see if our answer comes correct. So part 3, x plus 1 upon x the whole square is equal to this one, 5 root 3 plus 3 root 2 upon 2 the whole square. So a square b square 2 times ab, 5 root 3 3 root 2 upon 4. So this is going to be 5 square 25 into 3 75, 3 square 9 into 2 18, 5 2s are 10, 3s are 30 root 6 upon 4. So 75 plus 18 93 plus 30 root 6 upon 4. This is your answer for this and it is correct. Okay, so if you got it, brilliant, because this is a difficult sum actually, and if you got it, that means you're already prepared for your exam. You can rejoice. No, come back, let's do the next one. 10th, come on, can you handle same type? First find x square, then 1 upon x square, and then add the 2. Okay, so you just take x and square it to get your x square right over here, because there is no denominator to rationalize. So I will get x square as a square plus b square minus 2 into ab. So what will I get? 25. 2 square 4 into 6 24. 5 2s are 10, 2s are 20 root 6. So it's going to be 49 minus 20 root 6. That's our x square. Now 1 upon x square. So 1 upon 49 minus 20 root 6. And therefore x square plus 1 upon x square. So now let's take this and add the 2 together. So 49 minus 20 root 6 plus 1 upon 49 minus 20 root 6. Am I correct? So this is x square. 1 upon x square. I should have taken the rationalization part of this. I forgot that. So here only we should have rationalized it actually. Okay. Anyway, since we didn't do it, let's do it now. So keeping this intact, and 1 upon 49 minus 20 root 6 into 49 plus 20 root 6 upon 49 plus 20 root 6. So what will I then get? 49 minus 20 root 6 plus in one bracket. Here when I multiply 49 plus 20 root 6 as it is, and this is going to be a square minus b square. Bapre, this is going to be too huge to calculate. So let's take another sheet. 49 minus 20 root 6 as it is, okay, in one bracket, and this 49 plus 20 root 6 we are keeping it as it is right now. Whereas in the denominator you have 49 square, which is going to be 9 square, 81, 8, 9, 36, 72, 88, 16 plus 8, 24. Likewise 20 square is 400 into 6, 2400. So this is just going to be 1. So finally I can say 49 minus 20 root 6 plus 49 plus 20 root 6. So this plus and minus gets cancelled. 49 plus 49, 98. And that's how you can get your answer. Isn't it a lovely question? Yes, it was. I am sure you managed it and you have made yourself proud. Let's go with the next one, sum number 11. 11 is a simple question, only looks lengthy. So you pick up LHS. You have to prove that all this is equal to 5. How? So you take each part and you rationalize it. How? Obviously with its conjugate. So let's put brackets so it looks neat. Again minus 1 upon 2 root 2 minus root 7 into 2 root 2 plus root 7. So 2 root 2 plus root 7. Again all brackets. Likewise the next one, 1 upon root 7 minus root 6. Root 7 plus root 7 plus. The third one, 1 upon root 6 root 5. So root 6 plus and root 6 plus. What are we doing is only taking the conjugate, nothing else we are doing. No rocket science here. And finally root 5 minus 2. So root 5 plus 2. Root 5 plus 2. Got it? Now numerator 3 plus 2 root 2. Denominator a square minus b square. Exactly same way the next one, numerator 2 root 2 plus root 7. Denominator 2 root 2 whole square minus root 7 square. Again plus root 7 plus root 6. Root 7 square minus root 6 square. Then minus 1 into anything, so root 6 plus root 5. Root 6 square minus root 5 square. And plus root 5 plus 2, root 5 square minus 2 square. So finally 3 plus 2 root 2, this is going to be 9 minus 8 because 2 square 4 2s are 8. Likewise 2 root 2 plus root 7. So 2 square 4 2s are 8 minus 7. Root 7 plus root 6, 7 minus 6. Root 6 plus root 5, 6 minus 5. And finally root 5 plus 2, 5 minus 4. All the denominators you are getting 1. So what is left in the numerator is 3 plus 2 root 2 minus, so change both the signs. 2 root 2 minus root 7 plus root 7 root 6, again minus, so change both the signs. So minus root 6 minus root 5 and plus root 5 plus 2. So cancels plus minus plus minus plus minus plus minus. What is left is 3 plus 2, which is equal to 5. 3 and 2 over here totals 5. That's what your RHS is. So after this you can write, therefore LHS is equal to RHS. Ha! Lengthy question but easy. And you can expect such sums in the exam. So if you've done it properly, 100% you will get your marks. So don't worry about it then. 12th, put a star besides it. Actually, it's a lovely question. Here they say again simplify or rationalize the denominator. It's tough. So the easiest way is, what you do is you first take all the positive terms in one bracket and negative in another bracket. So now you get two terms. Let's call this A and B. So what will be my rationalizing factor is A minus B. So A plus B. Likewise root 3 plus 1 plus root 2. Getting it? That's how you can begin now. So now start building on it. If you get stuck, come back, which I expect you to. If you do not get, brilliant. So try. Let's see who can take the challenge. So root 3 plus 1 plus root 2. You can open the brackets in the numerator. Denominator A square minus B square. So now root 3 plus 1 plus root 2. This is going to be A square B square 2AB. And here minus 2. So root 3 plus 1 plus root 2. Denominator 3 plus 1 4 minus 2. So 2 root 3. Now, still the root is not gone. Our target is to remove all the roots. We could manage to remove one, but the second one is still left. So what you need to now do is, first take what is common. So I can see 2 being common, and now this part take the conjugate, that is 1 minus root 3, and now take it forward for the second time. So basically we are rationalizing the denominator twice in order to get both the roots out, because there are 3 terms. Okay, so now I can say root 3 plus 1 plus root 2 into 1 minus root 3 in the numerator, denominator 2a square minus b square in big brackets. Okay, let's see how can we take it forward from here. Now it's not very difficult, we've already solved it. You'll have to multiply these two. So I'm just writing it now. In the next step we'll multiply, so we don't do any mistakes. Okay, denominator 2 times a square is 1, b square is 3. Now let's open the bracket. So root 3 minus 3, 3 multiplied with both. Now 1 multiplied with both, so 1 minus root 3, and then root 2 multiplied with both, so plus root 2 minus root 6 upon 2 into minus 2. So now here what is happening? Root 3 gets cancelled. 3 minus 3 plus 1, so minus 2, plus root 2 plus root 6 upon minus 4. Better way of presenting, remove this out, so minus 1 by 4, and write this nicely, that is root 2 minus 2 plus root 6, and leave the sum like that, because you got rid of the root. That's what we wanted. Now what is in the numerator doesn't matter. Denominator root is gone, you are sorted. So do you understand? Double rationalizing factor. First here by making the group, and second time here after pulling 2. Otherwise you might get a different answer. So first pull out 2 and then work it out further. Okay, moving to the next question, 13th one. They have given you the values of root 2, root 3. So you just normally start by rationalizing first. Don't be in a hurry of substituting the values, that we'll do later. Okay, so 3 minus root 2 is the rationalizing factor. So in the numerator, denominator a square minus b square. So 3 minus 2 root 2, 3 square is 9, 2 square 4 2s are 8. So 3 minus 2 root 2 upon 1. So 3 minus root 2 is 1.4. Now you substitute. Okay, so 3 minus 2.8. So your answer should be 0.2. Easy. Exactly same as 13 part 1 and 3. You just have to substitute this in the end. So I thought I'll show you the flow and then you can easily handle it. Moving to the last question, 15th. Can you stop now and try on your own? One sum at least. Okay. So x and y is given. You need to find x square, y square, and then subtract. So first thing I would always suggest, rationalize the denominator and then square it. Don't square first. Okay. So 2 plus root 5, 2 plus root 5. So I will get 2 plus root 5 the whole square, a square minus b square. So this is going to be 4 plus 5 plus 4 root 5 upon negative 1. Okay. So 9 plus 4 root 5, and let this minus sign be outside. Now I can square it. So minus 9 plus 4 root 5 the whole square. Don't open this minus sign, otherwise you will mess up. Okay, let it be outside. Now square it. So minus ka square becomes plus. So your minus is gone. So a square, b square, because 4 square 16 5s are 80 and 8 9s are 72 root 5. So basically 161 plus 72 root 5 is what is x square. Likewise now work out for y. So y is 2 minus root 5, 2 plus root 5. So conjugate 2 minus, 2 minus. So I will get 2 minus root 5 the whole square, a square minus b square. So basically a square plus b square minus 4 root 5 upon 4 minus 5. So which is going to be 1 again. So 9 minus 4 root 5 upon minus 1. Again bring this minus outside. Don't open it. Okay. So this is y. So y square will be minus 9 4 root 5 the whole square. So again minus ka square becomes plus. So what do you have then is a square, b square minus 2ab. So that is 72 root 5. So I'll get y square as 161 minus 72 root 5. Don't you think we've done the same sum earlier? It is actually the same sum earlier, trust me. Now for the last part, x square minus y square. So let's take another sheet, x square minus y square. So let me take this over this one. So this goes up And now x square minus y square. So let us substitute the values. So what is x square? 161 minus 72, sorry, plus 72 root 5. So 161 plus 72 root 5 in one bracket minus 161 minus 72 root 5. That is what the value of y square we have already found. Open the brackets, magic will happen and you are sorted. So minus plus, this gets cancelled. So what is left is this plus this. So 144 root 5 is the value of x square minus y square, and that's it. So that was a good question. Again, I hope you're getting all these sums and you're really enjoying all these videos on the Roughbook app. If you are enjoying, please let your friends also know. There is something called as a referral code policy to get your discounts also. So let us know if you're referring and we will help you how to go about it, and let us spread the family of Roughbook. Until the next video which I make, maybe one day or something, take care, stay safe, pray for everyone and be honest. Bye.
Hope you had a lovely mathematics experience with the Rough Book, our learning companion.